Ratios, tables to graphs. This is a digital lesson. And the lesson starts with having students look at a table here. And we want to determine whether it's proportional. If it's proportional, then each of the ratios are going to be equivalent. So we're going to have the students compare with the most simplified ratio, the smallest numbers, 1 to 4. And we're going to determine whether they are equivalent to all the other ratios. So 1 to 4, is it equivalent to 3 to 12? And students can look at this and see that if we multiply the numerator and denominator by 3, we do get an equivalent ratio of 3 to 12. So those two are equivalent. We're just going to click and hold on this little red oval and use it to cover yes. Now we're going to compare 1 to 4 to 9 to 36. Are they equivalent? Well, I can see that if I multiply numerator and denominator by 9, I do get an equivalent ratio. So here again, I'm going to move this to cover yes. They're going to do that with the other two ratios, or the other three ratios also, 20 to 80, 5 to 20, and 12 to 48. They're going to find out that all of them are equivalent. And what does that mean if all of the ratios in the table are equivalent? Go to the next slide. Is it a proportional table? Yes. So they're just going to move this large oval to cover yes. Now, the next slide, students are going to be taking the values from this table, the x and the y values, and they're going to be creating ordered pairs that they can plot on the coordinate plane. So here they have 0, 0. The x-coordinate comes first, the y-coordinate second. 1, 4. And these are pretty simple, but it just reinforces for the students how this is done. 3, 12, 4, 16. So they're going to type those in. Now on the next slide, they're going to be taking all of these values and they're going to be using these movable points to plot them on the coordinate plane. And this is just quadrant 1. So here we have the point 0, 0. They're just going to click and hold on these red points and move them into place. So here's 0, 0. We have 1, 4, 2, 8, 3, 12, and 4, 16. Now the next slide, it states that because every proportional graph is a straight line through the origin, it's always going to include the point 0, 0 of the origin. So we know it's a proportional graph if it's a straight line through the origin. So on the next slide, students are just going to be determined whether these are proportional graphs. And we can see that only one is a straight line that goes through the origin, so we only have one proportional graph here. Now on the next slide, students are going to determine whether this graph is proportional by plotting the points and then seeing if it's a straight line through the origin. So here we have 0, 5, 1, 10, and so on. They're going to plot all of the points, but they can see here that it doesn't go through the origin. So is the graph proportional? They're going to type in no. They're going to do the same thing on the next graph and the next two graphs. So they get a little bit of practice plotting points and then determining whether it's a proportional graph. When they get to slide 12, now they get a word problem here, and students can actually turn this into a poster. They're given a word problem that at the ice cream shop, 1 scoop costs 25 cents. 2 scoops cost 50 cents, 3 scoops $1, 4 scoops $2, and 5 scoops $3. Is the ratio of scoops to cost proportional? So we're going to start with creating a table here. The number of scoops, so we can see here, and these are movable. So 1 scoop, if we look back at our problem, is 25 cents. So I'm just going to click on this, click on that little blue square, and I'm going to move that into place. 2 scoops is 50 cents, so I'm just creating my table by moving these numbers into place. 3 scoops, $1. 4 scoops, $2. and 5 scoops, $3. Now I've created my table, and now I'm going to just type in the ordered pairs. So I have 1, 25 cents. I have 2, 50 cents. I have 3, $1, 4, $2, so 4, 2. And the last one would be 5, 3. Now I have all of these points that I can plot on the graph. 1, 25 cents. And it asks us here, so if you notice this, they asked a question, will there be a point at 0, 0? So you want students to think about this. If there are 0 scoops, is it going to be 0 cost? Well, yes, that makes sense. No scoops, no cost. So they want to make sure they place a point here at 0, 0. Then they've got 2, 50 cents, 3, $1, 4, $2, and 5 is $3. Now, is this a straight line through the origin? No, it curves up. So we know that the proportion, the ratio of scoops to cost is not proportional. And students are just going to type in that explanation on the very last slide. This is not proportional. The ratio of scoops to cost is not proportional because the graph does not show a straight line through the origin. So that is digital lesson, ratios, tables to graphs.